Friends, I am indeed happy to welcome you to the second Saturday lecture series at IUCAA. I think something like 25 years this series has gone on, and it is always a pleasure to talk to school children, and I hope you will ask some questions at the end. And in case I can't answer them, or if there is not enough time, you can always send me an email, and in that way continue your question. Also, I am not keeping very good health, so in case I cannot go on halfway through the lecture, you know, in a cricket match, if a fielder is hurt, a second fielder can take its place. So I am expecting Samir to play the role of substitute speaker for this talk. Anyway, let's hope that doesn't happen. So what I am going to talk about are some aspects of heavenly bodies which collide in space. Now, when you look at the night sky, you see stars here and there, and then in between there is dark space. So you think that the space is kind of very sparsely populated, and therefore there can't be any collisions of two objects in space. But that doesn't happen, and we will see today that the collisions which happen in a big city crowd, that kind of collision can also happen in space, and it can happen at very different levels. So we can see how that can happen. Can we sustain collisions in the space which is all around us, and how big are the collisions likely to be? So let us look at this. So can we have collisions? The answer I am giving you in advance, yes. And we will see some examples of colliding objects. And we will start on the level of, if you see galaxies, which are collections of stars, like our Milky Way is a collection of stars. And you see here, you define a galaxy as a system of stars and interstellar matter that make up the universe. And you can have something like 100 billion stars in a galaxy. So a galaxy can be very large. Here you see a galaxy which is very familiar to us because we are in it. This is the what you call this spiral structure is made up of stars actually. All these things that you are seeing, the starlight is showing through this bright thing, and whenever there is darkness, it could be because, not always because there are no stars, but because there are absorbing matter, pieces of absorbing matter, that is light cannot move through, that part because of absorption, and therefore you see darkness. So we can ask, can our galaxy, and our galaxy is not the only one. There are many other galaxies that we see. So we can look at some galaxies which are well known. Here you see a galaxy called Stephan's Quintet. Now this quintet means five, a group of five. So they go around each other in a close group, and maybe sometimes they come so close that they collide. Okay. So this is another example. You see here a galaxy with a long tail on this side, and another galaxy coming from the other direction. Here it is, and they are colliding. So this is an example of colliding galaxy. You see here that when the galaxies collide, they are made up of stars. So these two stars, sets of stars, they go through each other. Now I can give you an example. Now that we are in the rainy season, if you go to a place like Lonavala where there is a lot of cloud, you see two clouds going through each other, and that is something like what is happening here for galaxies on a, of course, much larger scale. So this is another example. The names are given below: NGC 325956 in Bela. Now many astronomical objects are labeled by some catalog number. So NGC is new, N for new and galaxy catalog, something like that. So we have such galaxies. Here you see a lot of examples put together. You see that there is no unique way in which galaxies can collide. They can take various shapes and forms. Now we come to a collision which might be relevant to us. This is the galaxy Andromeda, which is our nearest neighbor. And if you look at the way this galaxy is moving, astronomically you can measure the speed of a galaxy coming towards you or going away from you with the help of spectroscopy. And there is an effect called Doppler effect, which helps you to measure the speed as well as direction of motion of the galaxy. So here what we are finding in these observations is that Andromeda, which is a galaxy similar to ours, we are looking at it from our point. And what we find, to maybe to our disturbance, is that these galaxies are, this galaxy is coming towards us. That means it's going to collide if you actually follow it. So it says here above in the slide, collision scenario for Milky Way and Andromeda galaxy encounter. So sooner or later they are going to collide. Now you might be worried as to whether they will collide today or tomorrow. So it is not that urgent. It may take millions of years before the collision actually happens. And of course it will be catastrophic when that does happen. But we don't need to worry about it right now. So here you see Andromeda galaxy and Milky Way. So this is Milky Way and this is Andromeda, and they are moving in our galaxy also moves relative to Andromeda, and so it will collide. Some more examples. So now what I will do, I will come down in the size, and from galaxies I have come to individual stars. You remember I said that there are 100 billion stars in a galaxy. So now we are going to a smaller level of kind of a phenomenon of collision, which you see here. System, the most common one is what is called binary stars. Now what do binary stars do? Binary stars go around each other. Binary means two, a group of two. So they go around each other, and when they go around each other, they radiate gravity waves. This has now been confirmed, and when gravity waves are radiated by binary system, what will happen is that since it is losing energy, the stars will start to come closer and closer. That binary system gets smaller and smaller because it is losing energy. And it may happen, if you wait long enough, if the stars coalesce. That means they hit each other, and that's a collision, and they merge into one. This can happen. So here you see binary star collisions. They are going around each other and supposed to be coming closer and closer. Now, how can I stop it? Okay. So we see here, this is, what I showed was two stars going around each other. Now recently, this kind of binary system has got a very striking example which astronomers have never seen before. What happens is the following. When you take two stars going around each other, supposing one star is a black hole. That means you cannot see it, but it exerts its attractive force on the neighbor, the second star. So you will see only one star going around, and you will wonder where this star learn to go round, because Newton's law of motion tell us, first law says, if there is no force acting on it, a body will continue to move in a straight line with uniform motion. So if we are seeing one star only, we expect it to move straight in a straight line with uniform motion. Now, what we are seeing is it's going around in circle. That means there must be some force on it, and that force is, we deduce that it was exerted by a companion star, and that companion star we cannot see because it is a black hole. Now the black holes have been seen that way, seen in inverted commas, but we cannot actually see it, but we can know that it exists there. So that kind of example tells you that you know there is a black hole because you see a visible companion which is going round. Now, supposing you have two black holes going around each other, how will you know there is a black hole? Because there is no effect on the companion. Companion is also a black hole, so you can't see. So how do you see? How do you know that such things exist? So the answer to that is that instead of light wave, if you look at gravity wave, then when two black holes going around each other collide, they will radiate gravity waves, and such waves have been seen, and from that we deduce that there are two black holes. in space. Okay, let's go further. So now we come to even nearby objects, and nearby in relative terms, that is in our solar system. So what is the likelihood of the Earth being hit by another body in the solar system? That is the question one could ask in general. Having seen examples of galaxies colliding, stars colliding, now we are on an even smaller scale, planets colliding or something else colliding in our solar system. Is it possible? Is it likely? That is the question. And the solar system, if you examine, what does it have? It has, of course, the sun, which is the master of the whole solar system, controls their motion by gravity. And then we have planets which go around the sun. You see here some planets, and we can go further. Planets have satellites going around going around the planets, and some of them are named here. This is not the whole list, but some important ones I say here. Then we have asteroids, which you see are of special interest to us, as we will discover today. The situation is that you have here the sun and then various planets going around, starting with Mercury, then Venus, then the Earth, etc. But you find that after Mars and before Jupiter, you have these bits of very small pieces relatively compared to planetary sizes. You can say this was trying to become a planet but could not become a planet, so it remained part of a whole distribution of smaller particles. So these are called asteroids. And then we can go further. We can have comets. Asteroids stay relatively nearby in our solar system. Comets come from very far away. As you see here, a comet is shown, and that comet will come from very far away, still attracted by the sun, goes around the sun and then goes away back into long distance. So that is another body. Then there are smaller pieces like this. You see pieces of stones which are called meteorites, and one can ask this question. Now that you have seen what solar system is made of roughly, you can ask this question, which is, in particular, can this Earth be hit by any of the objects that we saw in the previous list? Let me remind you. You see here, the solar system has the sun. Sun, of course, stays where it is, and we quietly go around it. So we have nothing much to fear from the sun. There is the question of planets. Planets have their own routes, and they seem to be following them without any great disturbance. So planets are not going to collide. What could happen, by the way, if some other star which is very far away eventually comes in the neighborhood of the sun, and like the collisions we saw earlier, you could have this star colliding with the sun or going very close to the sun. Then that star, either by himself or with all the planets it also has brought, those two bits will collide and a lot of things can happen. But there is no specific example here, so we can forget it and go further. So let's go to this question: can Earth be hit by any of them? So as I said, there is no problem from planets or the sun, but that is sun, planets and satellites. They are relatively fast and moving very quietly. But there are problems from the other objects in the list. They were asteroids, meteorites and comets. So if you take these objects, they are smaller in size, but there are more of them, and some of them could come very close to us. So there is a chance of collision. So there was the example of collision that we saw in 1994. I think most of the audience would not have been born at that time, but some of us were, and here you see 1994 July, a comet called Shoemaker-Levy may collide with Jupiter in 1,000 years. That is, a typical comet will collide against Jupiter once in 1,000 years. Why does it do that? Imagine the comet is coming from very far away, and when it comes close to Jupiter, which is very massive planet, its gravity is strong enough to pull it towards itself. And so that planet, comet might fall on the Jupiter. This is what happened with Shoemaker-Levy, and you see a picture. People knew when this was going to happen because the speeds were all well determined by astronomers, and once you know the speeds, then you can do a mathematical calculation using computers to tell you when and where that collision will happen. So this thing had happened in July 1994 as per prediction. This is what I want to say. So we can ask if the Jupiter attracts these comets, why can't the Earth do that? So the answer to that question is that the Earth is not massive enough. So its gravitational pull is not so strong as of Jupiter, and therefore, fortunately one could say, the collision with the Earth, like the Shoemaker-Levy collided on Jupiter, that will not happen once in 1,000 years, but it may happen once in 1,000,000 years. So you need to have that comet come close to where this Earth is located. So if you take this Earth here, comet is coming close to it, then it might be attracted. But if it is going far away, then the Earth's effect is not very large. But if there were Jupiter there, Jupiter would have attracted those comets. So here you have the problem that there are certain objects which are smaller in size, which could collide with the Earth, and therefore we have to worry about them. So it says here, impact of a comet may have killed life on the Earth, like the dinosaurs. So there is a mystery which has not been solved completely, but there was a whole population of dinosaurs on the Earth, and today you see no dinosaurs, but you see skeletons of dinosaurs, and you therefore know that they did exist. So what happened to them? Why did they not survive? So the answer has been that something came from the sky and hit the earth, and when it hit the earth, it produced lot of disturbance, it produced combustion, and when there is combustion, oxygen is used, as you know. So if oxygen is all used up, there is nothing left for the dinosaurs or whoever was living on the earth at that time. And so that is what may have happened. So the question was, is it likely that any comet will hit the earth? We would like to know that, and the answer to that is the comet Swift-Tuttle. Now, all these names that you see here, Shoemaker-Levy, Swift-Tuttle, etc., you may be wondering where these names come from. The answer is, if you discover a new comet which has not been seen before, then the comet comet is given your name, the discoverer's name. So sometimes two people discover independently. So this Swift-Tuttle might have come like that. Shoemaker-Levy was similar like that. So the most we can ask about, what about Swift-Tuttle comet? So first calculation showed a few years ago that this comet is going to hit the earth sometime in the future. I think it is given somewhere. Let's see. You see, it passed us safely in 1992, but at the time when it passed us, people said, let us know when it is next coming, because it comet go around the sun, so they keep coming again and again. And they discovered that the comet will come again about 200 years later, on 14th of August. So one could say, yes, in the year 2126. This is what our calculation shows. Now, what would you call this phenomenon? You can say that if the comet is going to strike the earth, we are all finished, like the dinosaur question. So one route is to say there is no future beyond 2126. And this is what many alarmist people say. There was some similar thing which said about 2 or 3 years back that the earth will be ending by some catastrophe. It didn't happen. So that the other possibility is that this calculation is based on motion of objects under law of gravitation. But there are little forces like friction which also produce some effect, although not very large. So if you imagine that this is the comet coming like this, and here is the earth and is going to hit it, that small force might alter your calculation and the comet may go close by and go safely away. So how far these friction forces will be important, this will be decided closer to the time when the comet is again seen. So we need not get alarmed by this particular situation. The third reaction would be, supposing you know that the comet is going to hit you, how are you going to save yourself? Now, dinosaurs did not have the technology to boast about, but we are technologically more advanced. So can we save our earth from from this comet. Now, so a few years ago, I had written a science fiction story about a comet which was seen by an Indian observer, and that comet was subsequently followed up by various scientists, and they found that the comet was going to hit the Earth. So how did they save themselves? So this, and that method can be used in a realistic manner. If you send a spacecraft with a nuclear device towards the coming comet, now it would be silly on your part to fire that nuclear bomb on the comet. It's coming here, I want to destroy. Because that nuclear bomb will break the comet into little pieces. But those pieces will keep coming to us, because the momentum when it was coming fast, that has not been destroyed by the collision. And therefore, what will happen is that you will get a shower of very sharp stones, and that will also be the end of the Earth. So what do? You fire this space vehicle to go very close to the comet, and then you produce a shock wave nearby, and that shock wave is a kind of change of pressure and so forth. You then produce an explosion around it, but not on the comet. So that will push the comet slightly to one side, and when it pushes it, the comet will change its direction very slightly, but that is enough to go close to the Earth. So now what, but save the Earth. I can give you an example. When you are crossing a road and a car suddenly comes, and so you have to do some maneuvering. So you move slightly to one side and the car goes safely away. So this is possible if what we are doing is, what is coming to hit the Earth, we are trying to change its direction slightly. So this will be a possible situation to worry about in future. Now let us do. So this question is, sizes matter. What hits you? It would depend on what size it has, and one can say that various things can happen. Now here is a heavenly body shown against here a big city. A big city is like this, and the stone is so big that it is more or less covering the whole big city. So this is the kind of things we have to worry about. So here you see previous impacts of stones like the one I showed earlier. They are called meteors. That is, they are hitting the Earth. And you see here, this is the meteor crater in Arizona, with big hole that has been made, because some big stone hit it. So of course that produced a lot of local disturbance and took away a lot of life, but it was not enough to kind of destroy the whole Earth, life on the Earth. So we can ask, do we have any other example? And this is the one in India. If you have not been, you should go and see. This is the lunar crater, which you see here. Again, it's almost circular, and the stone must have come like this, hit it, and it was made of various minerals which melted because of the heat generated, and that minerals, those got mixed with the underground water, And so this particular composition of this water in this crater is different from any other normal water reservoir in the neighborhood. So people have used this LONAR to estimate what was this meteorite which was hitting, which caused this LONAR pole. We can say that it was, the stone was weighing some 20 million tons. Now you work out 20 million tons, what kind of volume it will have. This came about 50,000 years ago. So this impact happened there. And this is in Buldana district of Maharashtra, Lonar is there. So it is not very far. Once you go to Ajanta and Ellora for sightseeing, you should ask your parents to have one more day and go to Lonar from there. You can make a day trip to Lonar and see this spectacular lake which has been created by this impact from the top. So how much energy was consumed by solar impact? We can do a calculation that the Hiroshima bomb, you remember the first atom bomb, released an energy of 13 kilotons of TNT, that is the local explosive unit. The lunar impact will have released around 6 megatons. So you see here, this was 13 kilotons, and here we are talking of 6 megatons. That much. So it is about 500 times the Hiroshima bomb. So you can see how powerful that impact must have been. And you see here, this is the Hiroshima output. So that kind of thing we have to keep in mind. So an impact of this order can destroy local life but also jeopardize other parts of the earth, as a lot of oxygen is consumed in combustion process and would enhance the danger. So we can say, what about asteroids? Now meteorites are relatively smaller. Asteroids can be bigger, and one can see that there are a possible dangers. So what people are doing, they are mapping all the asteroids as they are moving going past the earth and going around the sun. The advantage of this is that if you know for each stone, each asteroid, when and how it is moving, then they can, we can be certain that these asteroids are harmless, but a particular one might show indication that it might hit us. So that is where the advantage of keeping a complete record of asteroids is important. So astronomers are now engaged in searching for tracking and studying every possible near Earth asteroid, so that we keep for the future. So 30th June was the asteroid day for this purpose, to remind us of the importance of asteroids. And this project looks for major asteroid trajectory and provides details on the possible collision, as I told you just now. So this is the kind of telescope which is looked and used for looking for asteroids only. So this is part of NASA's defense program, and you see here that a lot of work is being put in. And people sometimes ask, astronomers take make observations of the sky, they have no relevance to what is going on the earth. So why do we worry about it? So I am telling you, this is an example which shows that it is very important to know what is in the sky and how they are moving, because it is necessary for our survival. So, this I told you. So to conclude, one can make this particular comment. In general, astronomy will give you instances which you don't come across on the earth. So be prepared for very what I would call unusual surroundings and unusual findings when you do cosmic research. Thank you very much. I will stop here, and if you have any questions, quickly you can try.
Okay, my name is Sridhar and I am from New English Medium Secondary School.
Can you speak louder?
Okay. I just wanted to ask a question, that what is the composition of a comet or an asteroid?
You see, like planets have different compositions depending on the distances from the sun. You find that asteroids will also have minerals of different kind depending on they are very close to the orbit or whether they are going very fast. So I don't think there is a uniform formula, but you need to examine each asteroid for its own composition.
Good morning, sir. My name is Aditi Sambare and I am from SPM English Medium School. I just wanted to ask that does the collision of meteors, comet or asteroids have a severe effect on other objects in the solar system?
Solar system has different, what I would say, different problems depending on where you are in the solar system. So as you saw, the comet hit Jupiter. So Jupiter has the problem of attracting, the problem arises because it attracts all these comets and therefore it suffers collisions. Fortunately it is very big, so these collisions are not very dangerous for Jupiter. For the Earth, the answer is different. If you went to Mercury, which is even smaller, then you will have further different problems. So you have to look at it planet by planet.
I'm Rupa Kulkar from Adelsworld School. So I wanted to ask that when the substance comes in our environment, usually it burns out. But why is it not in the case of meteorites?
You see, certainly some bits which come down, as we know, they get very heated because of friction in the atmosphere and because of large temperature. Some of them melt or burn out. So it would depend on the size of the stone. If the stone is very big, then although surface-wise it might have what we call burning or heating, it is big enough to survive that. So the meteorites that we are talking about for lunar or this thing, they were too big and the atmosphere can't protect us from those.
When we see comets have a tail. They burn due to the reaction with sun. So when comets go farther from the sun, do they have tails?
See, normally a comet is made of frozen material. So as it comes near the sun, because of the heat, that frozen surface part, it becomes sort of gaseous. And the pressure of the sun's solar winds and as well as solar radiation pressure. They push the tail away from the sun. So when the comet comes like this, the sun is pushing its tail back, the tail is behind. But when it goes around the sun and returning, then you see that its tail is on the wrong side, but in reverse. Because the sun's pressure is still there, so it is pushing it in this way. But the comet has gone like this, so the tail was at the back. So you don't see exactly the same picture.
Hello sir, I am from Bharatiya Bhavan. I want to ask that when some objects are sucked by black holes, what happens to that objects?
Okay. Normally a black hole is expected in the cosmos to be about at least 4 or 5 times the solar mass, because in order to become black hole, it needs strong gravity and pulling together, so the mass has to be large. So when the sun falls or goes hits the black hole, the black hole will attract it, and the sun can't go out again. So it is part of the black hole. It will go on increasing the mass of the black hole. So that's it.
As the asteroids the destruction is placed when asteroids are collided with Earth, does the sun have like effect of having such effect on the sun when asteroids or meteors collide with it?
Asteroids impacting the sun. The sun is much more massive, so there is not going to be much effect. So something very small hitting the sun won't change anything.
Good morning, I'm Neha from Vidyapatha School. My question is, what happens to the meteorite or the asteroid which collides with the Earth to form a crater like the one in Lonar?
See, when the meteor hits the Earth, first of all it has come with a big momentum. So that meteor will try to penetrate the Earth, but will come to a rest. When it comes to a rest, it will have already dug a hole or dug a kind of crater. So what happens is that in the process, the impact has generated lot of heat, and when that heat is acting on that same meteorite, it will melt all its compositions, all the metals or minerals, they will be melting because the heat is tremendous, and so it will become liquefied, and when it becomes liquefied, it gets mixed up with water on the side from below, because there is gone where the heat, and therefore that will produce this effect that you see.
Thank you, sir.